Okay, so here we have a quadratic function. The first thing that we want to do, so we're going to sketch the curve. So the first thing we would like to do is talk about the properties. So we know it's degree 2. So if it's an even degree, we know that the ends should go in the same direction. And it has a positive leading coefficient. So the ends should be going up. All right, so we know that they're both going to go up. Okay, so if we want to be, so that's sort of what we know in our mind what it's going to look like. It's going to have degree 2. It's probably going to turn once. The ends are going to go both up. And we're going to narrow it down by finding our x-intercepts. So we're going to find the x-intercepts, or the roots, by letting y equals 0 and factoring. So we'll set it equal to 0. It's just a simple trinomial, so we should be able to factor it easily. So we just want two numbers that multiply to get negative 32 and add to get negative 4. So I know 8 times 4 is 32, and I wanted to add to negative 4, so it would be negative 8, positive 4. And then I take each root, set it equal to 0, and then I can solve for x. So these are my two x-intercepts. So those are 2 points on my sketch that will help me graph it. So I'll start the sketch over here. So I've got one x-intercept at 8 and one at negative 4. So we'll plot those on there. The second thing I might be able to determine is the y-intercept. So in this case, x equals 0. So we'll just put in 0 for all these x's. And we end up with a result of negative 32. If the number is really big, you can just plot it on the graph and then just label it. You don't have to actually go to 32. Okay, so this one's at negative 4, 0, and this one's at 8, 0. And I know it's going to go up. Where is the vertex? Well, if it's a quadratic, I could find the vertex, because I know how to do that. So I'm going to find the vertex. We know that we could do negative b over 2a to find the x coordinate. So it's going to be minus negative 4 over 2 times 1. So the x-intercept will, or the vertex will occur at 2. And then I could plug that 2 back in to find the y. So we get 4 minus 8 minus 32. So that's what, negative 36. So my vertex is a little bit lower than the y-intercept. It's over here at 2 and negative 32. Let's move this over a little bit. And so that gives me a few points that I could use to sketch my curve. I know it's going to point up, it's going to pass through the y-intercept, go through the vertex, back through the other x-intercept. And I know the line of symmetry goes through the vertex, which should be in the middle. Right, there's my line of symmetry. Goes right through the middle at 2. And that is halfway between negative 4 and 8, so that is correct. And then that is my sketch. So those are things I can find. I know before I sketch it what it's going to look like. I know it's going to go up. I know it's going to have ends in the same direction, and I know it's probably going to turn once. And then through the process of factoring, I can find the x-intercepts. I can sub in 0 to find the y-intercept, and I also know how to find the vertex if it's a quadratic. Okay? If you have a polynomial greater than x to the power of 2. So let's say x to the power of 3. Okay, so this one we'll have to factor in a different way. Okay, so we can state the degree. We already know that. So the degree is 3. The leading coefficient is 1, so it's positive. Okay, so we know that it's degree 3, so we know the ends are going to go in opposite direction. We know that it has a positive leading coefficient, so we know it's probably going to look something like this. Okay, it's going to go uphill. It's going to start at the bottom and end at the top. So now we want to factor. So I'm just going to write out the equation here, minus 3x squared minus x plus 3. So it's not a quadratic, it's a cube or power 3. So I need to find a root, right? I need to find a 0. So I'm going to use my factor theorem / remainder theorem to find a 0. So I want to put in a number that's going to give me 0. So looking at these values, the n number is 3, so I could try 1, minus 1, or I could try 3 or minus 3. So I'm going to try 1. So what's that give me? 1 minus 3 minus 1 plus 3, that gives me 0. So there is a 0. From there, I know that x minus 1 is one of the factors. I could do several things from here. I could continue trying to find zeros, right? I could put in minus 1. I could put in 3. I could put in minus 3 to see if I could find the zeros that way. I could do long division now that I have one factor, or I can do synthetic division now that I have one factor. So I have 3 options. I think let's do long division, just for practice. Okay, so I'm going to start with a number that I multiply by x to get x cubed would be x squared, and then we multiply. Then we subtract to see what we have left. So negative 3 plus 1 is negative 2x squared. Bring down the next term. Negative 2x. Multiply and subtract to see what we have left. So negative x minus 2x is negative 3x. Bring down the 3. And one last multiplication gives us a remainder of 0. So what are my factors? My factors are x minus 1. We already found that first. And then the quadratic that's left is x squared minus 2x minus 3. And once I get it down to a quadratic, I can factor that. So 3 times 1 is 3. It has to add to negative 2, so negative 3 plus 1. And then those are my factors of the polynomial. So I can see that if I continued to try to find zeros, I would have found a 0 with negative 1, right? F of negative 1. And I would have found another one with f of 3. Right, so if I did f of 1, I found that 0. I could have done f of negative 1, that would be that 0. And I would have done f of 3, that would be that 0. Right, so I could continue with the whole process of the factor remainder theorem. I could do long division once I had one factor, or I could do synthetic division. Another thing I could have done now that I look at this is I could have factored by grouping. Right, sometimes that's an option. So here's my polynomial, x cubed, what was it? So I could have factored by grouping. If I group the first two and the last two, common in the first bracket is x squared, so I could have taken that out. The second bracket starts with a negative, and there's nothing common, so I'd put a 1. That's a minus. Because two negatives make a positive. And then x minus 3 is common. I would have x squared minus 1 left over, which is a difference of squares. And I would have factored it. So there's 4 different ways you could factor that. Right? You could factor by grouping. You could factor by finding zeros, right? So just plugging in numbers out of those 4 options. Or you could find 1 0 and do your long division or synthetic. So whatever process you prefer, you have 4 options there. Okay? So my x-intercepts are at 3, 1, and -1. So I'm going to start graphing. So I've got 1 at 3, 1 at 1, 1 at -1. Oops, that's not -1, that's -2. And I know sort of what shape it is, so now I'm going to find my y-intercept. So I'm going to put in 0. And we put in 0 the equation. Oh, where's my equation? So it's 0 and 3, right? So it's up here. I am not really going to be worrying about your turning points. You can just sketch it from here. So I know it's going to start at the bottom. It's going to turn, come through the y-intercept, go through the x-intercept, turn, come back through and go up. If you wanted to be more accurate about turning points, the turning points are generally found halfway between the roots. So this is more of an approximation, approximately halfway between the x-intercepts. Right, so my x-intercepts are at -1, +1, and 3. So one turning point would be halfway between -1 and 1, which would be at 0. And then another one, right, because it would be -1 + 1 divided by 2, which is 0. And then the other one would be between 1 and 3, so we could find the halfway point. So add them together, divide by 2, and the other one would be at 2. So that's approximately where they occur, right? So in actual fact, in this polynomial, the turning point is the y-intercept because I have a turning point at 0. So that is, it's not always the turning point, but in this case it is. So this one turns through the y-intercept. And then it turns somewhere at 2. So over 2 down here is the other turning point. Okay, you don't have to do that. That's entirely optional, but that's how you would find them if you wanted to find them. You could just find the halfway points between those x-intercepts by adding them together and dividing by 2. And then you would just plug them back in to find the y, right? If I wanted to find the y that goes with x equals 0, I would just put 0 back into the equation. And that would give me the y. So y would be 3, and then I would do the same with this, right? I would just plug that 2 back into this equation, and that would give me the y-intercept. So why don't we just plug that in? So it would be 2 to the power 3 is 8. Minus 3 times 4, so minus 12. Minus 2 plus 3, so it would be at -3. Okay, so if you wanted to, that's entirely optional. But if you wanted to find them, that's how you would find them. Okay, let's do another one. So here we have the polynomial x to the power 3 minus 13x squared plus 36. So let's state the degree. The degree is, again, 3. It has a positive leading coefficient. So it's going to look like the last graph, right? It's going to go uphill. Okay, so let's see if we can factor this. Negative 13x squared plus 36. Okay, so we have an end number, a constant of 36. So the options that I could use to find my zeros are, well, 1 goes into 36, 2 does, 3 does, 4 does, 5 doesn't, 6 does, 7 does not, 8, 9 does, 10, 11, 12, and then 36. So those are all my options, right? There's lots. So you could find your zeros just by plugging in. I'm going to try to find a zero. Let's see. I know 1 and negative 1 is not going to work. Just looking at the numbers, I can see that 1 and negative 1 are not going to get me a 0. So let's try 2. So we've got 8. Let's see. 13 times 4 is 52 plus 36. I don't think that's going to give me 0. It gives me negative 8, so that does not work. I could try negative 2. So that'll give me negative 8. That's not going to work. That's not going to work. That gives me a 24. So let's try 3. So 3 to the power 3 is 27. That's not going to work. That gives me 54. So let's try 4. Make sure I'm not missing any terms here. Hopefully we can find a number. Sometimes you'll get it on the first time and sometimes you won't. Sometimes it will take a few efforts here. So let me double check on our Desmos here. Oh, somebody's got a question. Yep, thank you. Just 1 second. Just want to make sure it's factorable. Sometimes I write down questions that are given and they're not factorable or they're decimal. Okay, I think this, oh, no. No, I think this one is questions written down wrong because I'm typing it in on Desmos and all the x-intercepts are decimals, which means that you can't factor. So it must be missing a number. Maybe it's an x. Let's try that. Might be missing an x. Let's type in an x here. Yeah, I think it's missing an x. So let's add an x here. Okay, I'm going to erase this. I think the question was typed in wrong. Let's just go up to the top here. I think that's missing an x. Okay, so if it had that x there, so let's fix that. We could have a common x factored out. And then we can factor from there. So let's just go with that. So 16 is, or 36 is 1 and 36. 2 and 18 is not going to work. 3 and 12. 3 and 12 is not going to work. 6 and 6. 9 and 4. 9, 4 is a 36, minus 9, minus 4 is 13. Okay, so we have 3 x-intercepts at 0, 9, and 4. So that will get us started on our sketch. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So 0, 4, 9. My y-intercept is 0, 0. Right? When I put in 0, I get 0. And I know it's going to go uphill. So it's going to start at the bottom. It's going to turn. It's going to turn. And it's going to go back up. Again, if I wanted to find these turning points, I would just go halfway between 0 and 4. So this one would occur at 2. And then halfway between 4 and 9 would occur at approximately 7.5, right? So I could then find those. So my turning points would be between 0 and 4, halfway, so at 2. And then the other one would be between 4 and 9, and then halfway, so divide by 2. Would be, what, 6.5? 6.5. And then you could just plug those values back in to the equation to find the value that goes with them. So if it was 2, what's my equation? It'd be at 28. And if it was at 6.5, it would be at 6.5. That's a big number. Let's try that one more time. 6.5 power 3. What is it? Minus 13 power 2. And plus 36. So minus 40.6. Let's say minus 41. Okay, so if you wanted to find those and be more accurate, that would be fine. If you didn't want to, you just had the sketch, that's fine too. So if I'm doing my end behavior, I know it's going to start in quadrant 3 and end in quadrant 1. Okay, so that is one of the sections on the guide where you have to sketch the polynomial. And those are the things that you would be expected to find. Describe the degree leading coefficient, find the roots by whatever method of factoring that you prefer, find the y-intercept, and then sketch the curve. If you want to find the turning points, great. If you don't want to, that's okay too. So the last part of that guide is word problems and applications. So we're going to do that on, what's today? Tuesday. So we'll be doing that on Thursday. And then that will wrap up most of that unit 5-6, and that's sort of the end of what you would be expected to complete for midterms, okay, by the end of 5-6. So let's see, I can't remember if you have a strand test or not.